Hello, this is the second movie from Lesson 9. I'm showing you this slide here. So when we do the problems with the bolted connections, we're going to be using this table for determining the strength of the fastener when we're doing our shear calculations. And then when we're doing our tensile calculations for the parent materials, we're going to be referring to Table 9, which tells us about, what is our stresses that we use, what is our strengths that we use for allowable bearing stress, and what strengths do we use for our allowable tensile stress, both gross when we're using the gross area and net when we're looking at the net area. I threw these two slides in here for the examples. Please review the example video. I'll be posting that shortly. Now let's talk about welding. So these are the types of welds we want to talk about. We're going to talk about groove welds and fillet welds. And then these are called plug welds, and these are called slot welds for joining materials. So those will be some of the terms that you need to know. Next is the types of joints. And this is how the metals are arranged for the welding. So in this case, this is a groove weld, but it's a butt joint. This is a fillet weld on a lap joint. These are fillet welds on a T-joint. This is an edge weld, and then this is a fillet weld on a corner piece. So these are the types of welded joints that you can see. Nice. And terminology of a fillet weld. In this picture, what we have is two parts with a fillet weld in a lap joint. Okay, so we envision that the filler material of the weld is shown here in these two triangles. It has a 45-degree angle, two 45-degree angles. The face of the weld is this surface that's exposed. The root of the weld is this vertex point right here, and the throat size is that distance from the vertex up to the face, perpendicular to the face. And then the leg size and leg size. So the strength of the weld is going to be determined by the leg size. Now, if we looked at an actual fillet weld, it's not going to be perfectly flat on the face. What you're going to do is you're going to have either concave or a convex where it sticks out. Both of them are about equal. I think the best one would be the concave. You can read about that in your textbook. But the real welds kind of look like this. They're not these, perfect right triangles. So the strength of fillet welds is a function of the size of the leg. Okay, so this is the way I want you to do this. They got a different method in your textbook, but I want you to use equation 19.8. 19.8 gives you an allowable load per lineal inch of weld. Okay, so what you do is you take 0.212, look at the derivation of this equation in your textbook. They're going through certain strengths of materials, and they're putting factors on there to get to the 202. This FU is the ultimate strength of the electrode material. So if the electrode material is designated as an E70, for instance, that material has 70 KSI. So to get the strength of a weld per lineal inch of the weld, this equation is used. Equation 19.8, it's 0.212 times the ultimate strength of the electrode material times the leg size. This chart here just shows you what the available sizes are for fillet welds. The smallest one is a 1/8 inch. And it's just based on the material thickness. Obviously, if your materials are thicker, you can have bigger welds. Okay. This next slide talks about the strength of the weld. Okay, so what this says is a fillet weld is slightly stronger in the direction where the load is applied perpendicular to the perpendicular direction. That's this one right here. It's slightly stronger in this direction than it is in this direction. So what we're going to do in this class, in this unit, we're going to assume that those are the same. I think your textbook says that in the perpendicular direction it's like like 1.3 times as strong as the parallel direction. Okay, so if you have a lap joint that has linear inches of welds that are both in the perpendicular direction and in the parallel direction, just add them all up together is what we're saying here. So assume the weld strength is the same in both directions. I'm going to let you read these two slides here. This talks about AISC provisions for fillet welds. So the minimum effective length of the fillet weld must not, this is for design, must not be less than 4 times the nominal size of the weld. If the weld is intermittent, the minimum length of each weld is 1.5 inches. Side or end fillet welds may be returned continuously around the corners for a distance not greater than 4 times the weld size, nor half the width of the part. This is called an end return. Its use is optional. Number 3, if fillet welds parallel to the applied loads are used alone, without perpendicular welds other than end returns, in the connections of flat plate tension members, the length of each fillet weld cannot be less than the perpendicular distance between them. And number 4, where lap joints are used, the minimum amount of lap should be 5 times the thickness of the inner part joint, but not less than an inch. So these are just basic design guidelines for AISC for joining. Now, we talked about strengths of welds for fillet welds. And the only other one we're going to talk about for strength of welds is the groove weld. Now, what we have to say about the groove weld is you don't need to go through this because the groove welds are going to be assumed to be full strength. That means that they are as strong as the parent material. So if you're going to do a tensile strength on them, you would do the tensile strength based on the section of the material. The groove welds are as strong as the parent material. And then see the examples. We're going to go through this one right here, and I'm pretty sure we're going to go through this one. And then this picture right here, this shows you what an end return is. So you're making this weld here, and then you're wrapping that continuously around from perpendicular to a parallel to the load to perpendicular. So you're wrapping that around this end. So that's what an end return is. Okay, that concludes this for this chapter.